Hello everyone, in this video we will find the Fourier series of the sawtooth wave in terms of voltage and time. As you recall in previous lesson, to find Fourier series of certain function, you have to go through a few steps. So in this case, we have to go through step 1, step 2, and step 3. Okay, so step number 1 asks us to determine the equation Vt of this function over the cycle of t and 0. So we are looking at this t and 0. To find the equation for this function, as you recall last lesson, I mentioned that for the sawtooth wave, you only have one equation to find. Okay, so that one equation is the red line that I indicated here. And to find the equation for this line, I am going to define two coordinates. And I'm going to use those two coordinates to find my equation. So I will use 0, 0. And I will also use this point as t, okay, period t for the t value, and then V max. Okay. So determine the equation Vt. So what we need to do in this case is, I will write to find Vt, what we need to do is we are going to use 0, 0, and we are going to use t and V max given the period t equal to less than t greater than or equal to 0. And as a reminder to everyone that we are using m y2 minus y1, x2 minus x1, y minus y1, m x2 minus x1. And these are the two equations that we are going to apply in order to find the equation for this Vt. And I'm going to identify my V2 and my V1 in this case. I mean my VT1 and VT2. Okay. Or we can just simplify it by saying x1, y1 and x2, y2. So I will write this one as x1, y1, x2, y2. Okay. So m is equal to y2 is Vmax, subtract 0. Here I should have period t subtract 0. So my slope is just simply Vmax divided by t. Okay, so now y minus y1, I will write it as Vt minus 0 is equal to the slope Vmax over t times the period, like here, like t, subtract the period which is now equal to 0, which is the x1. So Vt will be equal to Vmax over t times t. So this is the equation that I found. Okay, so it's very important. Keep that in mind. So we are going to write in here the equation we found is actually Vt is equal to Vmax divided by period t times t within this period. Okay, now they asked me to find the DC components A0. So to find A0, this is what I have to do. Okay, so find A0, I would like you to go to our formula sheet. Okay, on this formula sheet, it's giving me the formulas to find A0. So right here is A0. Alright. So for A0, I write it down as A0 equal to 1 over the period of t, integrate from 0 to t, and the Vt. Okay, so Vt is given to me as this equation, so you substitute it in here, times dt. Okay, So let's get back to, you see right here, it's just Vt dt. Okay, so Vt, I already found it as this, so I substituted exactly into this equation. Okay, I would like everyone to note that Vmax divided by the period. Okay, Vmax is the value that you have on your y-axis. So in this case, your y-axis is your Vt right here, right? Okay, and Vmax is the values on here. And your time domain is t, and your t is the values right on here. So they are constant. Basically they are constant. So you work with a constant in terms of the integral. You can bring that across the integral sign. Okay, right here what I have, I will bring it across the integral sign. So a naught equal to 1 over t times Vmax divided by t, and from 0 to t, t times dt. Okay, so in this case, how do we integrate this? Alright, integrate this part right here. Don't forget we are dealing with a definite integral, so we have to apply the fundamental theorem of calculus. So I will have a naught equal to Vmax over t squared, because I multiply the two denominators and I also multiply the two numerators. I have Vmax over t squared, and the integral of t in terms of dt will be a half of t squared, and I work with definite integral, so I have to evaluate this at 0 to t. Apply fundamental theorem. Where the t is, I should substitute it in with the period and subtract this in terms of evaluate at the t and the 0. So a naught now is my Vmax divided by t squared. In here I have a half, okay, a half. Now t, I should write it as the capital T, which is the period t squared, because I substitute exactly what t equal to. And the next thing is I will subtract that with a half. Now instead of t squared, I put 0 squared. You see that? I apply fundamental theorem in this case. And you know that this turned into a 0. And what I have is a naught equal to Vmax t squared over t squared times 2. Okay, so let's see what we can simplify. I can cancel that with that. So in here, I should have Vmax divided by 2 as a naught. Okay, so this is actually called the DC component. You take the Vmax, you divide it by 2, it will be equal to your a naught. Okay, so let's write it down on our chart. So this will be a naught equal to Vmax divided by 2. Alright, okay. So the next step, I would like everyone to take a look at this. The waveform has an odd symmetry. Okay, so it's an odd symmetry. I will have to, based on that, to figure out what Fourier coefficient that I have to find. Do I have to find A or I have to find B? Okay, in this case, you see that I identify for everyone you are finding B coefficient. So let's check to see why we are using B coefficient. Okay, so this waveform is odd. It's odd symmetry. Therefore, we only have the sine term. The sine term is this one here. That means you are going to find the B coefficient of this Fourier series. But this question asks me that I have to find it in, and I have to keep the n as unspecified n term. Therefore, I have to use these formulas. Okay. So let's write it down. Okay. So now what I need to do is I have to find Bn. Okay. Given the formula to find Bn is equal to 2 over the period integral from 0 to t Vt sine of 2 pi n divided by t, and this evaluate in terms of t. So now we are going to substitute what Vt equal to into this equation. And Vt, we found it as this equation. Okay, so we are going to substitute into here. Alright, so I am going to write it on the next line so that I can have room to integrate. So Bn is equal to 2 over t integral from 0 to t. My equation Vt, which I found equal to Vmax divided by t times t. Okay, so I put it in here, Vmax divided by t times t, and I still timed it with the sine of 2 pi n over t dt. Okay, as I mentioned earlier, this part here is a coefficient of t and is right on your graph, right? So on your graph, here's your Vmax, here's your t. So these are the actual numerical values. Okay, then this becomes a constant. So if it's a constant, you can go ahead and bring it across the integral sign. Do that to simplify the process of integrating. Okay, so Bn is 2 over t. Okay, and I bring this across the integral sign. I should have Vmax divided by t. Now, still have this inside the bracket. Okay. Alright, so how do we integrate this? Okay, to simplify this process, I actually give everyone the general formulas for this integration. So let's go to our page and we are going to go up to our formulas on page 11, and I want everyone to take a look at this number 14. Okay, so this number 14. Alright, okay, and we are integrate using the definite integral in this case, so you don't have to worry about the c, but you have to evaluate from the upper limit, subtract the lower limit, and apply fundamental theorem of calculus. Okay, so here what we have. So I am going to replace it by formulas number 14 on page 11 of. Alright, okay. So Bn equal to, I can write over t squared. Okay, I multiply the t with t and 2 with Vmax. And the next line is t over 2 pi n all of it squared, because I'm using number 14. And then I have it as sine of 2 pi n over t times t in this case, and subtract it with 2 pi n over t cos of 2 pi n over the period of t, close this bracket, and everything will have to evaluate from 0 to t, and I close the bracket. Okay, so apply fundamental theorem means that I need to evaluate the ft, subtract the f of 0. Okay, so I'm going to expand this square, and I will write everything as t square over 2 square pi square n square, and then I will simplify all this later. So now let's write the ft and the f of 0. Okay, so with the ft, it means that everywhere I see this t, it will be replaced by this t. That's my very first part of my fundamental theorem. Okay, so I'm going to write sine of 2 pi n over t. So where this t is, I will put in the t. Okay, subtract 2 pi n over t. And here is my variable t, but I evaluate that at the period of t. Okay, and then I multiply that with cos 2 pi n t, and then write the t right there. Right? Okay. Now, the next step is I need to subtract this f of 0. So where the t is, it will be replaced by the values of 0 as my next one. So that means subtract sine of 2 pi n over t. So now it will turn into a0, right? Okay. And then you are going to subtract with this part. So let me show you. You subtract this, but you subtract a negative value, so this should turn into a plus. Okay, so plus of 2 pi n over t. Now this will turn into a 0, and then cos of 2 pi n over t, and this turn into a 0, and then we close the bracket and close the bracket. So let's double check to make sure that we got substitute everything that we need to substitute. Okay, so that's what I have. That times cos of this and that. Sine now is a 0. 2 pi t multiplied by a 0, and this is a 0 as well. Okay, so now I can simplify a few things. I can see that I can simplify the t with the t, but let's write everything down first. So I have bn, and I simplify that with that. Okay, I simplify that with that. Okay, so what I have left is the Vmax over pi square n square. Okay, so what do I have inside the bracket now? We have that period cancel out with that variable t. So I will have sine of 2 pi n left. Okay, so this one, subtract that. That means I have minus of 2 pi n times cos of 2 pi n, because this was already cancelled with that one. Now subtract. This is sine of 0, so let's write it down, sine of 0. Add that with, okay, so right here, everyone should know that 0 times that is cos of 0, and cos of 0 is equal to 1. But you multiply that with a 0, so this whole term becomes a 0. Okay. So now Vn will be equal to Vmax divided by pi square n square. And now we are going to figure out what is sine of 2 pi n equal to. Okay, sine of 2 pi n equal to. So how do we figure that out? I would like everyone to go to our formula sheet again. Okay, on this formula sheet, we are going to try to find sine of 2 pi n. Okay, So right here, sine of pi n is equal to 0. Sine of 2 pi n is just basically, take a look at this. So you are going from pi to 2 pi, so it's still the same thing, okay? It's the same as 0. So I go back. I will make a note that I use number 3 of so this become a 0. Okay, so this I put right here as 0. Okay, so now minus 2 pi n, and I am going to look for the formula to find cos of 2 pi n. Okay, so let's go back to this formula sheet again, and right here is my cos of 2 pi n is equal to 1. Okay, so number 5. Okay, so that become 1. So I times this by 1. Okay, and then sine of 0 is equal to 0, and that is just 0. Okay, so now my Bn is equal to V max pi square n square. So I should, this seem to be a V, so I make that a 0. It's originally 0, but I wrote it like a V, so I just corrected to make sure that everyone realizes it's a 0. So time this value. Okay, so let's simplify to see what we get. Okay, I'm going to take the up here, I think I'm missing a 2. Okay, I will write the 2 back in. I'm missing the 2. You see that? It's right here. I have the 2. And I should write the 2 here. Now I'm going to cancel the 2 with this 2. This n with this n. This pi with that one. And in the end, I should have minus V max divided by pi times n. Okay, so this is the Bn as unspecified. Okay, so in this case, if you want to find 5 terms, okay, 5 terms for this Fourier series, then you have to have B1, B2, B3, B4, B5. Okay, and n will be 1, 2, 3, 4, 5. So what you have is B1 will be equal to minus V max divided by pi. B2 will be minus V max divided by 2 pi. B3 equal to minus V max divided by 3 pi. Okay, and B4 equal to minus V max divided by 4 pi. And B5 will be minus V max divided by 5 pi. Okay, so according to whatever n that you found here, this n, and if you replace n by the number that you need to replace, then you make sure that you include that into the formulas as well. Okay, so these are just the 5 Fourier coefficients, but we need to write the Fourier series of 5 terms. So we are going to go back to our formulas, and on these formulas we are going to look for the one that said Vt. So right here my Vt is this. Okay, so here Vt, I have A0, I have to write it, but I don't have any of this cos term. I have to find the sine term. So here the sine. Okay, you will replace your B1, B2, B3 with whatever you found, and then you have to put in the sine of all of this argument. Okay, So we almost done. Okay. So my equation for my Fourier series will be like this. Vt is equal to A naught. Okay, so A naught, that means V max divided by 2. And I'm adding that with B1 times sine of 2 pi t divided by the period of t. So I will subtract V max over pi sine of 2 pi tt, and I keep subtracting all the term that I have. So this one will be my B2, so I have 2 pi sine of 4 pi over t times t, and I subtract that with the V max of 3 pi and sine of 6 pi over tt, subtract that V max of 4 pi sine of, this time I will have 8 pi tt, subtract V max of 5 pi sine of 10 pi over t times t. And I need to simplify, so I am going to write V max over 2, and I will factor out this V max over pi. So inside the bracket I should have sine of 2 pi over t times t plus a half of sine 4 pi over tt, and then I plus that with 1/3 sine of 6 pi tt. Okay, and then I add that with 1/4 sine of 8 pi over tt plus 1/5 sine of 10 pi tt, and close the bracket. So I cannot simplify any further. So this is the Fourier series of the above waveform, and simplify to V max divided by pi, pull outside the bracket, and I include the A naught value as well. Alright, so for this particular waveform that we have as a sawtooth wave, our Fourier series is equal to, I can write it here, Vt equal to Vm over 2 subtract V max over pi inside the bracket of sine 2 pi tt plus a half sine of 4 pi tt plus 1/3 sine of 6 pi t plus 1/4 sine of 8 pi tt, okay, plus 1/5 sine of 10 pi tt. Alright, so this is actually the Fourier series for this sawtooth wave. Isn't that amazing? I hope everyone realized that adding all of this sine curve, individual sine curve, as many of this sine add up to be equal to this straight line. Alright, thank you everyone.